In this video, we'll use Excel to find Pythagorean triples. First, a little background. The Pythagorean theorem tells us that when we have a right triangle with sides a and b and hypotenuse c, then a squared plus b squared is equal to c squared. Now, if we want to look at this geometrically, we construct squares on each side of the triangle, and then the area of these two red squares, the ones on the sides put together, is equal to the area of this blue square. And in a Pythagorean triple, all of these areas and all of the sides will be natural numbers. So here I have illustrated a 3, 4, 5 right triangle, which is the simplest Pythagorean triple. Now for Excel, using Excel to find Pythagorean triples, we're going to be using the equivalent form for the hypotenuse, that c is the square root of a squared plus b squared. Okay, so let's get started. Now we're going to be using kind of a brute force approach, and we'll be making something that's sort of like a multiplication table, but instead of each entry being the product of the row and the column label, each entry is going to be the hypotenuse if these are the two sides. So it'll be the square root of the sum of the squares of these things. So let's see how that looks. And I also, in my video on the multiplication table, I go into the use of the absolute references in a lot more detail. So if you've never seen this before, you might want to watch that video first. So I'm going to put the formula here. I want the square root, and I'm putting this formula right now in this cell over here, cell B2. And so I want the square root of the thing all the way on the left, and so that means I'm going to put the dollar sign before the A so that I am fixed staying in column A. I don't mean the column just to the left of me, I actually mean column A. But I will let the row change as I move. So when I'm just saying a 2 here because I really mean row 2 right now. And then I'm going to square that. So that's one side of the triangle. And then to get the other side, I can let my column vary. So I'm starting out in column B, but that'll change. But I always want to be in that first row of labels. So I'm B $1, and I have just hit the wrong button. No big deal. I think I hit shift by accident or something. And then I want to square that. And that's the end of the formula here. So that's just our hypotenuse of the triangle. And I'll hit return here, turn off the magnifying glass. So if we have a triangle with one side 2 and the other side 2, the hypotenuse is about 2.8284. And now here's where we're going to go to the bottom right corner, get the fill handle, drag that formula. I went all the way up to 99 here. It's not going to show so well on the screen, but and then I'm going to drag this down. There we have it. Now to find Pythagorean triples, I just look for the whole numbers here. So there's the 4, 3, 5 and the 3, 4, 5 triangle. Here's another one, 6, 8, 10. We can kind of drag. Here's 40, 30, 50, and there's a lot of things in there. And this is a little bit visually overwhelming. So one of the things that I want to do here is color the squares that are Pythagorean triples so we can see them better. So I'm going to highlight the areas that I want. Actually, it doesn't really matter if I go too far, but I'll try not to. And we're going to use conditional formatting, which I've also used in some of the other videos. Okay, so to do this, go to the Format menu and choose Conditional Formatting, which is the bottom one on there. And we have a choice here. We want the second one where we put in a formula. Now, the formula that I want to be able to tell if I have a whole number here. And so what I can do, just like any other formula, I start with equal, and I'll put the formula in for cell B2. Now what I want to say is that int, which is the integer part of B2, meaning we truncate anything after the decimal point, we round down. In this integer part of B2, I want to see if that is equal to B2. Okay, because if the integer part is equal to the number itself, then I have a natural number, which is what I want. And then I can go over here and I hit this format button, and I'm going to, there's a few different things I can do, but I'll go to the one on the right, the patterns. I'm going to pick this lavender color. And there we go. Now I have my whole numbers highlighted. Now what I'm going to do is I'm going to just go to the column and make the width a lot narrower so we can see more. Now those things really aren't all whole numbers. They're just in cells that are too small. But you can see here that we have a lot of Pythagorean triples. Here's one, 39, 52, 65. We have a lot of them. You can see them better when you have a larger screen. You can see that there are some patterns here. I'll draw a line here. You can see there are lines of these Pythagorean triples. And in the second video, I'm going to talk a little bit about primitive Pythagorean triples, which are Pythagorean triples where there's no common factors here. You see on this line we have the 3, 4, 5, and then we have 6, 8, 10, which is really the same triangle scaled by a factor of 2. And then over here we have 9, 12, 15, which again is the original 3, 4, 5 triangle scaled by a factor of 3. So in the second video, we'll look at how to make the triangles that are primitive stand out. Okay, but this is enough right here for you to have, for students or anybody, to find a lot of Pythagorean triples. Just get a lot of data to look at lists and look at patterns, because there are a lot of wonderful patterns within the Pythagorean triples, and it's nice to find some of them for yourself.